Welcome everyone to the office hour session with Daniel. So I can see that some of you have been, playing around with testing, etc. This is something I encourage you guys to look into. And as I mentioned on the last meeting, we have a bounty for the best testing utility because it continues to be, it seems to be an area in need, basically in general, in Circom code bases. So I saw some of you guys are working on that, so it's great to see. But for today, I'll open the floor to you guys to ask any questions of Daniel, and he can share his screen as well in case it's relevant. So the floor is yours, guys. If anybody wants to ask questions, I can ask some of you guys. Igor, Oba, Antonio, I saw you guys have been playing around with testing. What have you been up to, maybe?
I haven't got yet to any good results to share, but I will keep you posted. But I actually do have the question on the to Daniel about the using of Ketchup inside the Circom. I'm wondering, what would be the number of constraints that you are getting out of using Bogdani Ketchup?
Right. So I think the Jack circuit results in about 150,000 constraints per hash. Might be wrong on the number, but it's quite big. But the Jack circuits are out of the scope of the audit, so I don't think we need to audit it. I don't think we need to run it. So yeah, I just wanted to clarify that if that wasn't clear.
Yeah, it's just like a basic interest.
Yeah,
like how much, because the verify is 8,000 constraints written in the repo. Yeah. Daniel, is it like 8,000 constraints that you're getting for verification of the public key?
Yes, the 8,000 constraints are the part that does the efficient ECDSA procedure, and that doesn't include Kijak. So yeah, if you add Kijak to that, it will be like plus 150,000, I guess.
Got it. Thank you.
So there's one question in the chat. The question is about, yeah, I guess everyone can see that, see the question. So the reason why we recreated the circuit again is it ended up just like two different constraints, but we weren't sure how much different it would be, considering that we have different constants. So it was more like a, let's just try this and let's just implement it ourselves and see how it goes. And also it's just, it is easier. We could just copy pasted everything. I guess we did that a little bit. We just referred to the Circom Lab implementation and implemented ourselves, but having our own implementation management wise and versioning wise, it is easier than forking Circom Lab and then adding our own constants. So yeah, that's why we just re-implemented these circuits ourselves.
Just to give context to people watching later, the question was about the re-implementation of Poseidon. And I think you, Daniel, touched on that and elaborated more fully in the last session as well. So people can refer to that regarding your constants.
I have a question to Daniel actually about the testing tool. Actually, I started working on some fuzz testing, but then I decided to be more interested maybe to work on mutation testing tools because I couldn't see anything for Circom. So it should probably help with improving the test coverage. I was going to ask if you have any suggestions or recommendations on what would you like to see in such a tool? So I'm thinking about something that can be easily integrated in Jest that we already use, and then compare the output of the mutated tests against the original tests. Do you have any like wish list for that kind of tool?
Let's see. I really haven't thought about fuzz testing, mutation testing, circumcircuits, but I believe having a tester that is compatible with Jest really makes sense because there is a library called Circom. I think it was called Circom Reader that loads circumcircuits into JavaScript that is compatible with Jest, which you can use other circum tester. The library name was circum tester that you can use. I think writing a mutation tester in JavaScript will make sense because we already have that library. So just sharing that context. And if you want to go deeper into the actual constraints and mutate the actual constraints, you could look. There is a specification for the R1CS that is compiled from Circom. It was a pretty I think there was a pretty lengthy specification of the R1CS. Let me see if I can find it. R1CS file. Yep. I'm sharing it in the chat. So the Git repository called R1CS file. I think it is a JavaScript tool to parse the R1CS generated by the Circom compiler. And I think there's a README about how the R1CS is formatted. So if you're interested in like using the R1CS directly, this might be useful.
Thanks, that's great. Thanks.
Thank you, Daniel, for answering my question earlier about the Rust implementation. To sort of just check, would a utility that allows you to compare between your Circom and your Rust implementation be of any use to make sure that the outputs you're getting are aligned?
Interesting. So firstly, if you have any other questions, please don't hesitate to ask. I'll try to answer as quickly as possible. About the tool or utility that compares outputs between Circom and Rust, will that be useful? It could, definitely could be. There could be some use cases. I think there is a project for testing if a circuit implements a formally audited, like formally defined circuit or computation. I think it was called. Let me just. Was. I think this one called. I think it's called Akine, I guess. I'll just say it. No, this is the fork. This is the one. Yeah. So this is a project written in Julia, programming language Julia, which is a tool for checking if a R1CS constraints implements a certain formally defined set of operations. Maybe having something similar in Rust, even just a simple tool to compare the outputs, might be useful when you just want to have a lightweight tool to test your constraints and avoid using a like full-fledged soundness tester like Akine. So that could make sense. And would like to if you have further ideas or would like to experiment on it, would like to hear more about it. So let me know in Discord.
Okay, thank you. Well, the idea is kind of you can give it almost like a fuzzing tool that compares between your Poseidon Rust and your Poseidon Circom, and you run them against each other. If one fails, it will report it. If they match, then you can get a match, and obviously just do a check after any code base updates or something like that. That was the thinking, but if it's not useful, then I'll abandon the idea and do something else. I don't mind.
Yeah, I guess a fuzzing tool. Yeah, I guess a fuzzing tool would be really useful. Yeah, so exactly what you described will be nice to have.
Thank you. I'll share. What is the tools that we are working on? What's the process to share?
So is the question, what's the process to share? Sorry, can you repeat it?
Yes, I think perhaps more directed to Ali to ask once we've got it sort of up and running and to a proof of concept, to just have a bit of a look. What is the preferred way to share the utilities we're working on?
You can share them on Discord partially, and we will curate them as part of the materials for the entire fellowship. So you can create it on your own GitHub, for example, and we will link to it. Maybe with a simple README on how to read it. But for quick feedback, maybe you can share it with the fellows on Discord.
Thank you.
On ECNI, Daniel, I believe it operates, or what it tells us is it proves the equivalence between the CAP polynomials and the R1CS function. So it's a formal verification. It formally verifies that the CAP completely captures all the constraints, if I'm not mistaken. This is based on my reading of the initial blog post.
Yeah, I think that's correct. Yeah, that's what it does. Yeah, it's a formal verification tool.
So the way I see it is probably it's a way to make sure that there is no dormant bug in the circumcompiler, which makes the CAP instance not correspond perfectly to the R1CS constraints, for example, as opposed to something higher level, meaning under constraining, for example. So let's suppose that the circuit has an under constraining bug. ECNI would still pass because it doesn't question the R1CS constraint themselves, if I understand correctly.
If there is so I think ECNI has a, let's see. I believe there is a way to check if a constraint is properly constrained by checking the inputs and the outputs of the circuit definition. If there is a variable that is not constrained by any inputs or outputs, that means that variable is a under constraint variable. So I believe I can check something like that. But yeah, I do recommend reading the README, and I believe they have a blog post as well. So to try it out or to try try to see what you can do.
There seem to also be some performance issues with ECNI. Antonio in the chat is mentioning that it takes 24 hours to basically test the circuit. So
Okay.
It's still early, I guess. It's still alpha, I think. Too.
Yeah,
But guys, if
that
you
sounds terrible too.
yeah, I think you guys, I'll see if I can invite someone from 0x Park so you can guys share your feedback. I'm sure they would really love to see your feedback on that tool, basically. In terms of unit testing, Daniel, I don't know if just a general question, is it possible to, well, I think it is possible, but have you guys, you, Daniel, or anyone, have you seen like a unit-based testing of Sercom, like a template level testing, isolated testing?
I've seen project using Circom having tests written in JavaScript, but I don't know. I don't know if there's something more general to that. But I believe I think the Circom-ECDSA repo and also a bunch of circuits written by the team in the 0x Park. They have a lot of Circom tests, I guess, so which might be good to refer to. But I don't know anything that is general that you might be able to use.
Yeah, I think it would be great to have a tool where you can, at the template level, it can generate dummy inputs just to, and it takes care of the whole plumbing of testing specific input to that just that template. I'm thinking, for example, of multiscalar multiplication and addition and all that. You can just fuzz it, test the zero input, all that stuff, just at a template level. I'm not sure that something like that already exists, which I don't think so.
Yeah, I've never seen anything like that. But so yeah, exactly why we want a fuzz tester, I guess. A fuzz tester would be nice.
By the way, Daniel, sorry. Do you know if there are any like code coverage tools for on Circom test? Because I couldn't see like if branches and all like the number of lines covered by the current tests and all that stuff.
Unfortunately, I've never seen a coverage reporting tool for Circom circuits. There might be something out there, but yeah, unfortunately, I don't know anything. But yeah, I'll definitely let you know if I find it or if there's something similar. Yeah, actually, I could look around a little bit.
Has any of you guys attempted the questions of the quiz?
I did do the reading and the checking of the answers. So I have some idea of them and did the checking for session 1 and session 2 answers. I'm not exactly sure what the answer for question 1 of session 1 should be. Are you looking for the actual base field, or are you just looking for that Q is a value of the base field in that question? Oh, sorry, not question 1, question 2. Apologies.
Yes, so got it. Yeah, so I was expecting answers so that I was expecting the answers to be the actual orders of the fields. So the question is, what are the base field and scalar field orders of sec q 256k1? So the field order means the size of the field. So like the base field is size n and the scalar field is size m, something like that.
Okay, all right. Thank you.
You're welcome.
But the others, yes, I did do. And then I went to that Sage Math website and ran the script and ran the other one, and then worried for the rest of the night that they were going to think I was trying to hack them because it tries to write a file.
Yeah.
But
I see.
but yes, yeah, no, I've been through them.
Amazing. Yeah, I guess the other one that you ran is the one that generates the actual constants. I don't think that's you can run
Yes.
that on the website. You can only
No,
run the
luckily
security input. Yeah.
Luckily, it fails on the system input arguments, so it didn't try to write the file. I was quite grateful
Okay.
for that. I have a question. Sorry. In terms of the implementations and the code that is very close to the code that you reference. In the code, you say this is a implementation of, and then give a reference to. If it's sort of almost exactly the same, are we still sort of to look at that, or are we to take that as kind of already well audited because it's implemented by something like Zcash or something?
Sorry, are you talking? I believe you are referring to the Poseidon implementation, Poseidon circuits.
Well, for instance, yes, or there's some of the I think one of them refers to Filecoin uses another one of the implementations, and you refer to it.
Okay, so yeah, I don't know if the circumlib is audited or not. So the actual implementation of the Poseidon circuits, which is really similar to the one in circumlib. I don't know if referring to circumlib's implementation and saying that it's safe, that's possible. I don't know if that's possible because I don't know if circumlib is audited or not. But the Filecoin, in terms of the usage by Filecoin uses the same spec. So we refer to the specification written by Filecoin, and we use the same specification used in Filecoin. So in terms of the design of the system, I believe it is robust because it's been used in the Filecoin system and then battle tested there. So the specification, so the design is secure, but the question is if our implementation actually correctly implements that and inherit the security. So that's the part that we want to check, I believe.
Thank you.
Okay. If there are no more questions, I guess we can wrap up here. Thank you, guys. Thank you, Daniel. And we have one more office hour session end of this week. There might be a speaker coming in to speak about implementation and optimizations of MSM this week, multi-scale implementation, which is relevant to this audit. So yeah, and then hopefully by like sometime later this week, you guys should be starting to, put down some stuff in your report and get feedback from Daniel. And a reminder, if it's something you suspect to be serious, tell Daniel about it privately first. So thanks, everyone. We'll see you on Discord.